Okay, just going to go through a few requests from exercise 11e, question 1 part D, which asks you to integrate 2 over root x brackets x minus 4 with respect to x. And you need to do this using integration by substitution. So integration by substitution requires you to replace all of the x's with u's. In this case, using the substitution u is equal to root x. So first thing I'm going to do is differentiate, because I need to replace the dx's with the u's, so that would be in index form x to the power of a half, which gives you a half x to the minus a half. Now I'm going to anticipate with this question that they want this not in index form as a square root, so this is the same as du by dx is the same as 1 over 2 root x. And if you make dx a subject, dx would be equal to 2 root x du. Okay, the other thing now is I want to make, so that substitution would be obvious. So root x with u is easy. Is this one obvious? So is it easy to make x the subject in this? And yeah, I'd agree so. So x as the subject, you get x as u squared. And now I'm ready to do this integration, call it I, and I is equal to the integral of 2 over, make the substitutions, root x is u, x is u squared, and dx is 2 root x, well remember root x is u, so 2u du. And if you simplify, the u's disappear and you're left with integrating 4 over u squared minus 4 with respect to u. Now this does look easier than that first integral. However, the method for this you haven't been taught yet. For some reason they're asking you to do something which is in 11.7. So 11.7 uses something called partial fractions. And that's the technique you need to finish this question off. I'm just going to very quickly go through it. Now, this algebraic fraction there, if you factorize everything, you get 4 over u plus 2 u minus 2 du. And partial fractions involve you splitting this algebraic fraction up into 2 separate fractions. Like so. And if you do that, you need 4 is identical to a u minus 2 plus b u plus 2, and if you picked u is equal to plus 2, that would be eliminated and you'd get 4 is equal to 4b, or b is equal to 1. And if you put u is equal to negative 2, that one would be eliminated and you'd get 4 is equal to minus 4a, a is equal to negative 1. And therefore this integral I is the same as integrating minus 1 over u plus 2 plus 1 over u minus 2 du. And these integrals you can do. So yeah, this technique is actually taught in subchapter 11.7. I'm not sure why it's in the book where it is, but okay, well these integrate to, well you should know that these go to lunds. That'd be minus ln u plus 2, that'd be plus ln u minus 2, remember the plus c, and you can actually write this as a single ln. So this is the same as ln u minus 2 over u plus 2 plus c. And if you want your answer in terms of x, remember u is equal to root x, so this would be the same as ln root x minus 2 over root x plus 2 plus c, and that would be it. So I wouldn't really worry too much about this one. As long as you could get to that step there, you're fine. You'll be taught how to do this next step in a future lesson, but that's how you would do it properly. What I did in green there is the correct method. But yeah, that's going to be taught in 11.7.